Our team at Biotic is collaborating with the Laboratory for Brain Recovery and Function to help people recover after a stroke. We are passively and non-invasively studying people's brains while they learn to do a task called motor imagery. Motor imagery is the mental performance of a movement. This means that you don't physically perform the movement while sitting in the scanner. Instead, you imagine yourself doing it by creating a picture of it in your head. The MEG measures your brain activity during motor imagery and figures out which brain areas are active in less than a second. The brain activity during motor imagery shows up on a screen that helps you know whether or not you're activating the right areas. We've found that people get better at motor imagery when they get the feedback from the screen. Dr. Shaun Boe at Dalhousie University's School of Physiotherapy sees this feedback as an important part of people's recovery after stroke. The problem is that the MEG scanner is hard for patients to access. To help patients access motor imagery feedback, we have moved our system to a cheaper and more portable brain imaging technology called EEG. Here is a demonstration of the new feedback prototype in the lab. A person is connected to the EEG system. In this case, the EEG is wirelessly connected to a robot. When she imagines her right or left hand moving, the EEG system transforms her brain signals into commands for the robot. After a few weeks, she can navigate the robot around a grid using her brain just like a remote control. In most types of learning and skill acquisition, we rely on feedback from our environment to tell us if we're doing well or poorly. Motor imagery is the same. Imagery has the potential to help people recover from stroke, and we think that feedback is the key to making motor imagery more effective. We hope that our research will lead to new ways for people to see how their brain is recovering, opening new avenues for stroke recovery. This research has been developed by Dr. Tim Bardwell at the Biomedical Translational Imaging Center and Dr. Shaun Boe at the Laboratory for Brain Recovery and Function.